Okay, today we're going to use the first Pythagorean hyperbolic trig identity that we calculated in the last video, and we're going to derive from that the other two Pythagorean hyperbolic trig identities. So kind of like with the just regular trig identities, if you take this ID right here and you divide each term by cosine h squared x, you get one of them. And if you divide everything by sine h squared x, you get the other one of them. So we're just going to do that, and we're going to see what that comes out to. So the first thing that we're going to do is we're going to divide everything by hyperbolic cosine x squared. So we're going to have hyperbolic cosine x squared over hyperbolic cosine x squared minus hyperbolic sine hyperbolic sine x squared over, it's quite a mouthful, the whole hyperbolic thing, over hyperbolic cosine h squared equals 1 over hyperbolic cosine h squared. X squared, x, but you get it. I've written it down correctly. So well, what does this become? This becomes cosine hx over cosine hx squared, because that's just one of the rules of exponentiation, is that a squared over b squared equals a over b squared, right? If you recall from like 7th grade or whatever. And then minus hyperbolic sine h over hyperbolic cosine h squared, same property again, equals, and now 1 is the same as 1 squared, right? So it's no stretch to say that this is the same as hyperbolic cosine x squared. So, and what we're doing here is just saying that 1 could very easily be 1 squared, so it doesn't make a difference. What we're going to see now, if we look at our definitions of the hyperbolic cosine and sine and all the trig functions, is that these are the IDs for other hyperbolic functions. So hyperbolic cosine over hyperbolic cosine obviously is going to be 1, right? So we're going to get 1 squared here, which means we're going to get 1. And then hyperbolic sine over hyperbolic cosine, if you recall, is actually hyperbolic tan. And since that's squared, it's going to be hyperbolic tan squared. Hyperbolic tan squared. And that's going to equal, well, what is 1 over hyperbolic cosine? 1 over hyperbolic cosine is actually hyperbolic secant. So this is going to be hyperbolic secant squared. And that is actually our first in this video. This is going to be our second Pythagorean trig identity. And I'm just going to highlight that. Okay, so that is done. Now we just have to do it once by dividing everything by hyperbolic sine squared. So we're just going to take the second half of the page. This isn't a really difficult concept, but sometimes you just have to watch someone else do it so you can understand it better. Let's change colors. All right, so we'll have hyperbolic cosine x, squared over hyperbolic sine x squared minus hyperbolic sine x squared over hyperbolic sine x squared equals 1 over hyperbolic sine x squared. Sine x squared. And just like, we're just going to use this property again. I'm not going to make it a full step as I did in the last one, because now you understand or you remember. But basically, this is going to become hyperbolic cosine over hyperbolic tangent all squared. So that's going to be, well, what is hyperbolic cosine over hyperbolic sine is hyperbolic cotangent. So we're going to have hyperbolic cotangent x squared minus 1 squared, which is 1, equals 1 over hyperbolic sine squared. Now, what is 1 over hyperbolic sine squared? It is a lot like the original trig functions. It's just hyperbolic cosecant squared. So we're going to have hyperbolic cosecant squared. So that is our second. Pythagorean trig identity that we get from this one. So when we put all these three together, these are our three hyperbolic Pythagorean trig identities. That is really a mouthful. I am probably never going to say it again after this video, but they are very helpful. As I said in the last video, it might seem kind of like, well, why are we doing this? But when you're trying to derive the inverse hyperbolic trig functions, you need these to get to the solution. So I hope that this was helpful, and I'm going to be deriving the hyperbolic inverse trig functions in some of the following videos.